We'll talk about the Fibonacci Nim this strategy games. The objectives and rules are shown here. The player 1 is not allowed to take all of the objects, and on each subsequent move, the number of the coins removed can be any number, that is at most twice the previous move, and the player who takes the last coins wins. So we suppose the upper number n to be the total number of the coins. We can first have a guess scenario 1, that is n is a Fibonacci number, like the 55. If n is equal to 2, then the player 1 must lose, since the player 1 can only take 1 and the player 2 then wins. And if n is bigger than 2, then we demote n1, n2 to ni as the first I Fibonacci numbers in the sequence of this kind of sequence, and we assume that n equal the first I Fibonacci numbers. Player 1 must lose. So we have to prove that when n is little n I plus 1, player 1 can also lose. Suppose player 1 takes m coins. Firstly, there are 3 different situations. The first is m bigger and equal to ni minus 1. In this situation, since ni is equal to ni minus 1 plus ni minus 2, which is smaller than 2 multiple ni minus 1, then the player 2 can take all the rest of the objectives. Hence, the player 2 wins. In the second situation, that is 1/3 ni minus 1 is smaller equal m and smaller equal ni minus 1. In round 1, the player 2 can take all the objects remaining here, so he will win. Or in the first round, he only takes x objects. Then x is follow kind of the inequation. And in the second round, the player 1 takes y objects. It follows this. This 2 inequation is from our objectives that on each subsequent move, the number of the coins removed can be any number that is at most twice the previous move. Hence, basing on our calculation, we can conclude that the player 1 cannot take the rest of the objects at the round 2. Hence, the player 2 wins. So, basing on these 2 results, we can also conclude that in the situation 2, the player 2 also wins. Then we come to the third situation, that is m bigger and equal to 1 and smaller and equal to 1/3 ni minus 1. The player 2 cannot take the ni minus 1 at once, so there at least have 2 rounds. In round 1, according to our assumption, there must exist one way to ensure player 2 take the last coin from ni minus 1. And in round 2, after taking ni minus 1 coins, if the player 1 cannot take the ni coins at one time, the assumption stands and the player 2 wins. Otherwise, if the player 1 can take ni at one time, and then the player 2 must take at least half of the ni when after taking ni minus 1 coins. So here comes our calculation. Because 3/3 ni is bigger than ni minus 1, hence the player 1 cannot take the ni at once. So we can conclude that the player 2 wins. Second scenario, that is n is not a Fibonacci number, for example 57. Basing on the second of scenario, that is every positive can be represented uniquely as the sum of one or more distinctive Fibonacci numbers in such a way that the sum does not include any 2 consecutive Fibonacci numbers. We get that such kind of equation is n, the upper end equal to plus ni2, ni1 plus ni2 until the nin. Player 1 can take the ni at once because ni1, ni2, or nin are inconsecutive. And as the double of the ni1 is smaller than ni2, hence the player 2 has to take from the ni2 but cannot take all of the rest coins. Hence, the player 1 can take the last one, so player 1 wins. Then we come to draw a conclusion is that if the n is a Fibonacci number, player 2 will win. But if n is not a Fibonacci number, player 1 will win. That is the winning strategy existing theory is when there is a Fibonacci number of objectives, there is a winning strategy for the second player. Otherwise, the first players can always win with optimal plays.